a message yesterday that today we are going to do a small activity which may help you with your exams. Actually, you may become part of making the exam. So what I will do is I will break you into groups, four groups. I will break you into four groups of four rooms. Group 1 and 2, room 1 and 2, will prepare an exam question from the topic of sport speed studies. So have your notes and your slides in front of you for sport speed studies and travel time studies. Okay. So group 1 and 2 will give, each group will give me one question from the topic of sport speed studies. Question can be theoretical or it can be a numerical problem. You don't have to give me the values. You don't have to give me the values, just the question statement is enough that we will be given this and we will be asking this. Or if it's a theoretical question, then you write the question. Group 3 and 4 will prepare one question each from the travel time topic, travel time studies topic. Okay, so group 1 and 2 will each prepare one question from sport speed studies topic, and group 3 and 4 will prepare each question, one question from the travel time studies topic. Okay, so I will give you 5 minutes. You prepare the question in 5 minutes. After you come back, you decide which one of you will write the question in the chat. So while you have the 5 minutes, write the decide which one will represent the group, and he or she just has to write the he or she just has to write the question in the chat, and that's it. So decide about your representative while you are discussing the questions. And one side note: when I break you into groups, you can chat with each other in Arabic or whatever language you want. I cannot hear you, I cannot see you unless I want to, and I will not interfere unless you ask me something. Okay, so while you are in the groups, if you open your mic and camera and start discussing with each other, it will take you less time. Okay, so don't worry that the doctor will be listening and what he will think about us. I will not enter the groups unless you are asking me to enter the group. Okay, so now I will break you into four groups. Group 1 and 2 will be deciding the question for sport speed studies topic, and group 3 and 4 will be deciding the question for travel time studies topic. And you don't have to give me the values, just a statement and inputs and outputs is enough. Okay, so I'm breaking into groups now.
Doctor, is this the group or did you forget to move us?
Sorry?
Is this the group or did you forget to move us?
No, it's taking time.
Okay.
Yeah.
Doctor?
Yeah.
Are we supposed to be a group? Because I didn't find my group.
I don't know, for some reason it's taking too long. I'm trying to open it again. Yeah.
Okay.
If it works fine, otherwise you can start the discussion here. Okay. I think it's working now. Should be in the group soon.
2 of them left.
Yeah. So you are the only two in room 2, so only you two are left. If you want, you can start the discussion. Okay. You are in the same group. Amna and you are in the same group. So
Okay.
even if you go into the room, you will go together. Yes, Hani and Amna, you can start your discussion here if you want. Okay. This is your group. Assume this is your group. Okay.
Okay, doctor.
And Hussein is with you now.
Okay.
Welcome back, everyone. So I hope you had a good discussion. I was seeing, was looking at the chat, and I was impressed that you guys are very active. Okay, so room one or group one, room two, group two. From each group, please, whoever has volunteered to write the question, please go ahead. So I need one question from each group. Type it in the chat. Okay, one question from each group. So I think you have decided who is going to type it. So just go ahead. Write room one or group one, then your question. Okay, like this. Okay, group one, well done. Before and after study. Okay, to define the effectiveness. Okay, good. Okay, although I said that you don't have to write the numbers, but well done. Okay, good. So this is similar to what we have done in the class. Okay, I think you changed the numbers. Okay, good, good. Okay, good. Group 2, 3, 4. Okay, group 2. Okay, okay. So you prepared a 3 question as well. Okay, well done. What is the difference between centered tendency and dispersion of data? Good, like it. What is the maximum length for a, where is it? It's gone. Maximum length for a spot speed study. Okay. What road segments are travel time studies conducted? Okay. You will give a graph. Room 3, you will give a graph between travel time given running time. This must be calculated. Travel speed and running speed. Okay. 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 That's well done. Well done. Bell shape. It should form the bell shape. It should form the bell shape. If you have taken the number of vehicles correctly, you should form the bell shape. That's a theoretical assumption. That we already know that from our theory type application of problem study. It has a test. Okay, good. Yeah, whenever you plot the frequency distribution curve for spot speed, it should follow the bell-shaped curve. If not, that means there is some problem with your data collection. Maybe you did not collect enough samples or something like this. Okay. Now what I want you to do is I will go question by question. Okay, and I just want you to raise your hands. If you think that you know this topic and if you studied, you would have answered this question, then you raise your hand. I'm not asking you to solve it right now. I'm just asking you that do you think if that the question is from a topic which you remember? Okay, I'm not asking you to solve now, but if you have any idea, like I know if I go back and see the equations, I can answer this question. Okay, or I know this topic. If you feel, just raise your hands. So how many of you feel that they can answer the question from group 1? Raise your hands. If you feel you can answer the question from group 1 before and after spot speed study, this one. Let me share the screen as well. Okay. So I'm talking about this question. How many of you feel that they can answer this question, or they know this topic and they can go back and have the equation and then answer it? Raise your hands if you feel that like that. How many of you feel that they know this topic or they can answer this question? Raise your hands. Anyone? And the people who gave this question should also raise their hands. Okay, so Haya, you should also raise your hands if you have given this question. I'm feeling that you know the answer, right? The question is very simple and it's similar to what we have already done in the class. Okay, so no problem. If you don't recognize this topic, later on after the class, the questions are in the chat and you go back and look at that topic. Okay, this is why I'm doing this exercise, so you know what to revise. Okay, so if you don't know the answer right now, if you don't understand the question right now, no problem. After the class, the questions are there. You go back and revise the topic. This is the purpose of this exercise, to get your brains moving and to check or to let you know how much you remember. Okay, if you don't remember now, obviously you will not remember at the time of the exam. So if you feel the question is something which is completely out of your mind, then that means that you need to do revision more rigorously. Okay, so who thinks that they know this topic, the topic of group 1, the topic which is answered, which is asked in this question, or who thinks that they can answer it? What about the people who were in group 1, Haya and her group mates? You posed this question, right? So you must know the answer, right? So at least you should raise your hands. Anybody who thinks they know this topic or they can answer this question, please raise your hands. Okay. Now, lower your hands now. Group 2. What is the maximum length for a spot speed study? Do you remember that we studied about it, or you know the answer? Raise your hands. Raise your hands. Mariam, Haneen, okay. Anyone else? Hashim, good. Haya, good. So Haneen, well done. Gave an easy question, right? Okay, no question is an easy question, because when it comes in the exam, you guys come under pressure. Okay, so lower your hands now, lower your hands. Group 4, on what road segments are travel time studies conducted? If you remember this topic or you can answer this question, raise your hands. Okay, good. Okay, then group 1 theory question. What is the difference between central tendency and dispersion of data? If you know the answer, raise your hands. Or if you know the topic, raise your hands. Okay, good, that's good. People who are not raising their hands, they feel that the questions are completely new to them. That means you need to go back and revise the topics, okay? Because these questions are not coming from me, they're coming from your colleagues. So they have also studied the same thing which you have studied. So if they can pose this question, then you should at least know the topic, okay? Okay, room 3, numerical question. Graph of travel time and running time, travel speed and running speed will be given, length will be given, and you will be asked to calculate running time, travel time, and delay. Okay, so if a graph between travel speed and running speed is given, and somebody asks you to calculate the travel time and running time and delay, how many of you can do that? Or how many of you think they can do that? I think this is very easy. The length and speeds are given. I think this is very easy. Many of you should be, yeah. Okay, even if you don't remember the topics from the slides, at least you should answer this. Okay, the theory question from room 3, applications of travel time studies and types of test card techniques. Theory question, types of test card techniques and applications of travel time studies. Okay, so everybody, well done. Again, the purpose was just to allow you to self-assess yourselves. Okay, so now you know how much your colleagues know which you don't know. Okay, and now you can put yourself in my shoes and you can imagine what can come in the exam. Okay, so these questions are there, they are there for you, there for me as well. It is recorded, it is written in the chat. Who knows, maybe 1 or 2 of these questions may come in the exam. Okay, so if it comes, then good, right? Good for you. Now we will move to the topic which we were covering, which was delay studies. Okay, so we discussed the procedure and the equations for doing delay study on a signal, on a traffic signal. Okay, so I showed you the equations and the procedure. Today we will do some examples and I will show you the procedure for calculating delay for roundabouts as well. Okay, so you see this is an example or a data which is taken from delay studies, a delay study of a signal. So the study started at 5 p.m. and it continued for 10 minutes. Okay. Observer one was counting number of vehicles in the queue after every 20 seconds. So you can see after every 20 seconds we have an observation. Okay. The cycle length for this intersection, the time from the start of the red to the start of the next red, is 60 seconds. So that's why you see 0, 20, and then 40, and then after 40, what happens? New cycle begins. Okay, so after 40, when you complete the next 20 seconds, you have completed 60 seconds, right? So at 60 seconds, you are at the start of the second cycle. Okay, so that's why you see the values up till 40, because after 40, the next one is the beginning of the new cycle. And you can see every row marks the beginning of the new cycle. Okay, so the value is taken in the first cycle, second cycle, third cycle, and so on. So each cycle is 60 seconds, means 1 minute, and we have collected data for 10 cycles. So that means 10 minutes. Okay, so these observations came from observer 1. Then observer 2 gave me these two values: how many vehicles arrived at the intersection and how many vehicles stopped at the intersection. So 120 arrived, and out of 120, 75 stopped. Free flow speed was done on this highway before they started the delay study. So free flow speed is 35 miles per hour. It is already collected. How it is collected, I already explained it in the last lecture. Summation of all vehicles in the queue, or summation of the queue counts, that is 132, which is summation of values from this table. Okay, the summation of all the values in these 3 columns. So if you sum all the values in these 3 columns, you will get 132. So summation of VIQ is the all the values, summation of all the values recorded by observer 1. Okay, let us begin with the calculation. Team notebook. So first of all, okay, let me read the statement of the question as well. This approach has 2 lanes. Cycle length is 60 seconds. I already told you. Data taken for 10 cycles. This is already also clear. And each vehicle in count queue was taken after 20 seconds. So all these things are very clear from the table. The only new thing is that we have done the study for 2 lanes. The first thing we need to calculate is TQ, time in queue delay. So in time in queue delay, I'll show you the equation. This is the equation. IS is the interval for the first observer, 20 seconds. Summation VIQ already done, 132 vehicles. Total number of vehicles given by observer 2, 120, and 0.9 is the constant. So 20 into 132 divided by 120 vehicles. TQ, time in queue delay. If you have any questions, you can ask. Okay. Don't have any questions? Calculate the values. How much is TQ, time in queue delay? $19.8. Okay. The units are seconds per vehicle. Okay, seconds per vehicle. Each vehicle is spending on average 19.8 seconds in the queue. Okay, then the next thing we calculate is VSLC, vehicle stopped per lane per cycle. Observer 2 gave me that 75 vehicles stopped. There are 2 lanes on this highway and the data is collected for 10 cycles. So how much is this? $3.75. Per lane per cycle. Okay, then we calculate fraction of vehicles stopped, which is vehicles stopped upon total number of vehicles. How much is that?
Doctor, 0.625.
Then we calculate the control delay. Okay, control delay is time in queue delay, which is 19.8 plus FVS 0.625. Correction factor. For the correction factor, I have a table. The table for correction factor. So I need free flow speed, which is 35 given, and I calculated VSLC, which is 3.75. So 35 is in this range and 3.75 is in this range. So my correction factor is 5. How much is the control delay?
22.925.
Okay, and the units are again seconds per vehicle. So this signal is causing an average delay of around 23 seconds for every vehicle. Okay. Moving on, there's another example as well. So this is the statement: signal cycle length is given 60 seconds. Find out time in queue delay TQ and the average control delay, which is D. So this is the same. Number of lanes are not given, so I will assume it to be 1. Number of lanes are not given, so I will assume it to be 1. Okay, this is the data. Okay. So signal cycle length is 60 seconds and they have collected data for 15 cycles. That means 15 minutes. Okay, each cycle was 1 minute. So from 9 to 9:50. Then you see the values are taken after every 15 seconds. So the interval for the first observer was 15 seconds. So 0, 15, 30 and 45, because after 45 you will go to the next cycle. 45 plus 15 is 60. So that is the start of the next cycle. So again you start with that. Okay. Values given by observer 2, total number of vehicles arrived 435. Out of 435, 305 stopped. Free flow speed taken before the study, 35 miles per hour. Okay. So I will start with the time in queue delay first of all. So time in queue delay, I need total number of vehicles given. Interval for the first observer, 15 seconds. And I need summation of VIQ. So summation of VIQ means sum all the values of these 4 columns. Okay. So I need the summation of values for these 4 columns. Column for 0, 15, 30 and 45. You can give me one value, do the summation for all of them and just give me one value, or if you want to do it column by column, no problem. Just give me the total count taken by observer 1, the total of all the counts taken by observer 1, summation of that. How much is that? Okay, summation of all these counts. Yes, anyone? $151. Yeah, too much. What can I do? Okay. Okay, so we know the interval 15 seconds multiplied by summation of VIQ 151 divided by total number of vehicles 435 multiplied by 0.9 is a constant. So how much is TQ? Give me the value of TQ. .69. Okay, then I can calculate VSRC, which is number of vehicles stopped 305 divided by number of lanes 1. I will assume it to have 1 and 60 seconds of 15 cycles. How much? How much is VSLC? 20.33. Then I will calculate FVS, which is number of vehicles stopped divided by total. How much is this? Seconds per vehicle. This is vehicles per lane per cycle, and this is 0.701. So now I can calculate total delay, control delay. Okay, so 4.69 plus 0.701 multiply the correction factor. So correction factor, again this table. So free flow speed is still 35 and VSLC is 20.3. So at this range. So you see the correction factor is negative. Correction factor is negative. And what effect will it have? I will tell you once we calculate the value. So what is D here? .98 or 3.99. Okay. In seconds per vehicle. Now, if you remember, I told you time in queue delay is part of control delay. So time in queue delay should be lower and control delay should be higher. But you can see in this question, it's the other way around. time in queue is higher, control delay is lower. Why? It could be because the queue is moving slowly, because of the design of the road, or because of the number of lanes are not enough. So the queue is moving slowly. So since the queue is moving slowly, more delay is caused by the queue as it would have been because of the signal. Okay, so if the queue was moving fast, the signal would have caused less delay. Okay, so this is the meaning here. So when time in queue delay is higher, that means there is a problem with the design of the road or maybe the number of lanes, because of which queue is causing more delay than the design of the signal would cause. Okay, so this is what we mean here. But usually in most of the cases, D should be higher than TQ. D should be higher than TQ. Okay, moving on. Calculation of delay for roundabouts. It's very simple. You just need to use this equation. Okay, so I will explain the parameters of the equation. First of all, D means average control delay seconds per vehicle, which we also calculate for signals. C is the capacity of the lane for which the delay is calculated. How much is the capacity of the lane in which you are calculating the delay? So that is C. How to calculate C? I will explain it in the next slide. T is the time period of analysis, okay, for which you take the flow, which is normally 15 minutes, and for 15 minutes it should be taken at 0.25 hours. Okay, quarter of an hour, 15 minutes is 0.25 hours, right? So T will be 0.25. Simply, T is 0.25. Why 0.25? Because flow is taken for 15 minutes. Okay, so T represents the period of flow, which is 15 minutes, 0.25 hours. So T will be 0.25. Then what is X? X is a ratio of volume upon capacity. Actual volume in the lane upon capacity of the lane. That is X. Volume upon capacity. Okay. So we need C and T and X. C is capacity, T is 0.25, and X is volume upon capacity. Then there is one small point here, which is about this bracket. Now you see 5 multiplied by minimum of X or 1. So X and 1 are not multiplied with each other, or both of them are not multiplied with 5. Either multiply 5 with X or with 1, whichever is minimum, whichever is lower. So for example, X is 1.2. So 5 will be multiplied by 1. Or if X is 0.7, so 5 will be multiplied by X. Okay. So if X goes above 1, then 5 will be multiplied by 1. If X is below 1, then 5 will be multiplied by X. You have to do one of these two things. Okay. How to calculate the capacity? For that, you must understand this figure. And this figure, you see, we have VC here. This is VE and this is VEX. VEX means flow rate exiting the roundabout, coming out of the roundabout. VC means flow circulating the roundabout, or they also call it the conflicting flow rate. Okay, so VC can mean circulating or conflicting flow rate, and VE means flow rate entering the roundabout, So VE is entering, VC is circulating or conflicting, and VEX is exiting. All of them are flow rates. Calculation of capacity of any lane, you will use the first table, and the second table is for correction factor. Okay, so first of all, you must know how many lanes you have on the roundabout and how many entry lanes you have. So as I explained, entry are these, how many lanes are coming into the roundabout, and lanes of the roundabout are these circular lanes, the circular lanes of the roundabout. Okay, so they can be 1 or 2, and the entry lanes can be 1 or 2. Depending upon that, you will calculate the capacity. So if you have 2 entry lanes, then the capacity of right and left lane can be different. So you have a separate equation for capacity of right lane and capacity of left lane. So whenever you have 2 entry lanes, you can be calculating 2 capacities as well. Okay, so first of all, check how many lanes of the roundabout and how many lanes entering the roundabout, and on the basis of that, you calculate the capacity. If pedestrian crossing is allowed on the roundabout, then you can see a pedestrian correction factor as well. So FPD means pedestrian correction factor, and its value depends upon the flow which is circulating the roundabout. Okay, VC. Okay, so if this is the range of VC, factor is 1. This is the range, then factor will be calculated like this, and so on and so forth. In these equations, you can see the term NPET. NPET means number of pedestrians crossing per hour in the peak hour. Number of pedestrians crossing the road in the peak hour. Okay, that is NPD. So if pedestrian crossing is allowed, then calculate the capacity, then calculate the factor, then multiply the capacity with the factor. That will be the corrected capacity. Use that value. Okay. Again, correction factor depends upon the lanes of the road. For one lane road, these are the correction factors. Two lane roads, these are the correction factors. Let me show you an example. I will show you one example. There's an additional example in the slides. You can try it, and if there's a problem, you can let me know. Okay. So in this example, we need to calculate delay of left and right lane. So 2 lanes. Calculate delay for both of them. It's 2 lane entry. Okay, 2 lanes entry, and 1 conflicting or circulating lane. So roundabout has 1 lane, and flow in each lane is given. Conflicting flow is 600, left lane 600, right lane 400. Okay. So first of all, I should calculate the capacity of this roundabout. Okay, for capacity, I have 2 entry lanes, but 1 lane of the roundabout. So I will be using these equations. Now in this condition, you can see CR and CL have the same equation. There is no difference between them. So capacity of both lanes will be equal. Okay, so let us calculate the capacity first. Capacity is 1130. Then e to the power, e means exponential, okay, exponential, minus 0.001 into conflicting flow rate, which is 600. Give me this value. This is exponential. Don't ask me from where did you get the value of e. Exponential. $620.16. Okay. So 620. You take 620. Okay. Then I can calculate x for the left lane, which is 600 upon 620, volume upon capacity. And then I can calculate x for the right lane as well, which is 400 upon 620. In this case, remember, both lanes have equal capacity.
Victor?
In some other case, it might not be the case.
Victor?
Yeah.
For number of vehicles rounding, we should round up or just round the normal rounding?
So normal rounding off.
Okay, thank you.
Okay, so this is for the left lane, and for the right lane, 0.65. Very good. Okay, now I will take these values because the equation is very long. So I will take these values here. So you will use this equation. Capacity for both lanes equals 620. Okay, so C is similar, but X is different for each lane. So you will calculate delay differently for each lane. Delay will not be the same for both the lanes. Capacity is the same, delay is not same. So give me the delay for left lane and right lane. These are the values. And T, as I said, 0.25, because 15 minutes analysis period for any hour. And in this case, you don't have to multiply 5 by 1 because both x values are less than 1. So x, 5 will multiply by x every time. So what is the delay for left lane and right lane? So while you people are calculating, if anyone has a question, has a comment, any query, they can go ahead and answer. They can ask me. Any questions, queries, problems, please go ahead. Otherwise, calculate the values. So like I said, there's an extra example given in the slides about roundabouts. So you can solve that as well. And if you face any problem, let me know. $54.7, yes. So D for the left lane, 54.7 seconds per vehicle, okay? Delay cost because of roundabout to each vehicle. The right lane, just need to change the value of x. 19.2, okay. So you can see when the flow is less, the flow in the right hand side lane is less. So X value is also smaller, it's also smaller, and the delay is also less. So whenever the flow is less, the delay will be less. Yeah, seconds per vehicle. Thank you. Seconds per vehicle. Okay, so thanks for listening and participating. I hope you enjoyed today or learned today something. And see you guys tomorrow, inshallah. All the best. Assalamu alaikum.